Today I wanted to share some ideas with you about templating in Ember, since Ember is becoming more and more template driven. Again, my name is Lauren. A bit of trivia, I was born in the year of the rabbit, and you can find me on the interwebs as sugarpirate_, or on GitHub as potato with an E. So when I don't work on open source, I sometimes play a game called Overwatch. It can be quite addictive. But thankfully, I have a little dog, Zelda, who keeps me grounded in reality. I think she's a year old, actually, and I miss her a lot. And here's a picture of her in the Netflix office, looking majestic. So yeah, a year and a half ago, I was still living in Australia. And then I moved to Boston last year to work at Dockyard, which is a software consulting company. And Dockyard worked on a lot of Ember, Elixir applications, as well as very many open source libraries. It's been an amazing experience working at Dockyard, which is why it was a really bittersweet moment when I left to work at Netflix on the Studio Apps team. So at Netflix, at the Studio Apps team, we basically built tools for producing Netflix originals like House of Cards and Stranger Things. So I got to move to California last Sunday, which is awesome. The weather is as great as you can imagine. And we're also hiring in Q4. So if you are interested in working at Netflix, please get in touch with me later. Okay, so the title of the talk is a bit of a troll statement. You could probably write an Ember app without handlebars, but you're probably going to have a bad time because you'll lose out on a lot of the things that Ember is good at. In case you're wondering why the talk is titled this way, it's a bad pun on a song called Handlebars by Flowbots, which is a cool song. And then, it would actually be a really cool trick to be able to write an Ember app without handlebars. But I think, just like a bicycle, handlebars exist for a reason in Ember. And when I was figuring out what I wanted to talk about, when I was coming up with this talk, I only roughly knew that I wanted to talk about helpers, because I think helpers aren't as popular as components are in Ember, and they're a bit not as well understood. So Jamie White, he's from the UK, he pointed me to a talk by someone called Guy Steele in 1998. And this talk is really interesting. It's called Growing a Language, and it posed some really interesting questions. So in this talk, Steele asked this question: should a programming language be small or large? On one hand, a small language is quick to learn, but it takes more work for you to be productive and get going. While a larger language is slower to learn, but there are a lot of tools already available for you to just be productive straight away. And during the EmberCamp keynote, where this talk was first delivered, as Tom said, Ember today would be considered a large language. Now, there was a quote from Guy Steele's talk that I really liked, but I think it's a little bit confusingly worded. So the gist of that was that language design is basically a pattern for making more patterns, or a tool for making more tools of the same kind. So let's explore that idea a little more. If you think about it, an Ember app is basically written in a language that you've designed, because you defined the vocabulary of UI in your application, and you do this using custom components, helpers, and other primitives in handlebars. And according to Steele, a language that's ideal for growth means that users can grow it themselves. For example, being able to define functions that look like and can be used as language primitives is a really good sign that the language can grow to suit your purpose and to feel more natural to use. And what you end up with is a very unique language of components and helpers, which is almost like a DSL, domain-specific language to your application. This is a Glimmer 2 only application built by Monograph, where Hassan and Tom Dale work. And this is actually not built with Ember at all, but if you were to look at the code for this, it's actually very similar because it's also written in handlebars. So there's that. Stay tuned for more, basically, about the whole story about being able to use Glimmer 2 by itself. The analogy here would be that Glimmer 2 is similar to React. Now, since templates make up such a large portion of our applications, we need to explore the question of how much logic we should have in our templates, because that's been a really contentious question the past few months. So we're going to talk about declarative templating, as well as what it means to have your UI as a language. And finally, we'll close off with some technical tips and tricks for writing good helpers. So a template is basically data with logic embedded inside it. And as we shall see, how much logic is a contentious question. Now, despite a very common claim, Handlebars isn't a logicless template engine. It only restricts what logic is allowed. And given the nature of UIs, a strictly logicless templating language wouldn't be very useful. And you'd probably be end up finding it more to do what you want. And template engines exist on a spectrum with sometimes very different philosophies. On one extreme, you have a template engine. This one's called Plates. In this template engine, all you can do is interpolate data into HTML, and there's no actual template logic. And the engine, in fact, encourages you to keep your templates completely logic-free. And then in the middle, you have engines like Handlebars and Mustache, which allow some logic, but they do enforce a separation of concerns. For example, here there is logic in the template, but the actual implementation of that logic is in JavaScript land and not in the template itself. And of course, you have your other extreme. This is JSX, by the way. On the other extreme, you have more flexibility and power is encouraged. So in programming, we don't often deal in absolutes because we're not SIF. One is not objectively better than the other, and it really depends on the circumstances. In Ember, the intention of Handlebars is to allow template authors to create logic outside of the template, and components and helpers encourage that separation of concerns by design. So even though it looks like there's logic in the template, the logic is encapsulated outside, and we use that helper in our Handlebars templates as a declarative way of handling presentational logic. But the thing to note is that you should avoid programming in the template. So sub-expressions or nested helpers in Handlebars have been around for quite a long time. In fact, I think they've been around for almost 3 years, but they've only recently become popular in Ember. And these are really great for composing helpers, and you can do some really interesting things with this pattern. But like any other tool in programming, this can be abused, and deeply nested sub-expressions are very much an anti-pattern and should be avoided. So here is an example of what I mean by a deeply nested sub-expression. You can see it's just pretty hard to read. And the point of a good template is to be declarative and to communicate intent. When you write something like this, you should really step back and think, why did I need to write this? And basically, avoid programming in the template. This is really hard to read, hard to test. And in this particular example, you're better off moving that logic into a computed property. Another way to look at helpers and to think about them is to think of them as computed property macros. If you find yourself doing a lot of boilerplate and repeating yourself a lot, it could be a good candidate for being extracted into a reusable helper. For example, many generic computed properties can be replaced with helpers. For example, there is an add-on I helped to write called Ember Composable Helpers, and it has a bunch of really useful helpers that function kind of like computed property macros. The logic isn't so extreme that it becomes programming in the template, but the upside of this approach is that you no longer need to worry about the dependent keys for a computed property, and this logic is more reusable in your template. But at this point, why not just use JSX if you wanted to write something like this? There is a rule called the rule of least power, also known as the principle of least power. And this originated from the W3C. The reason we use HTML to write markup documents instead of writing code to generate HTML is because of that rule. And this rule basically means to use the least powerful language for a given task. And like anything in life, this rule is also evaluated on a spectrum. And in some ways, it's really similar to the question of how much logic should live in your template. A language with constraints like Handlebars is straightforward to analyze, read, and easy to reason about. And components, helpers, and keywords let us express our unique UI in a language that is declarative, without having too much logic in the template. And the converse of this rule is to use the most powerful and flexible solution for a given purpose. And usually what that means, it's very imperative. You basically have to tell the computer what you want to do. But you can do anything because there are no constraints. But in fact, Handlebars is the reason why in Glimmer 1 we could optimize rendering. For example, here we know that this h1, the contents of this h1 is always going to be static, and that the p tag is the tag that contains the dynamic value. If you inspect the source when this HTML gets rendered on screen, this is actually what Ember renders. And what you'll see is that the p tag content was split over 3 lines. And what that basically means is Glimmer rendered 3 text nodes. Since we know that the only text node in this p tag that is dynamic is the name, that's the only one we need to watch for changes and update the DOM accordingly. So that's like a kind of really simple optimization that Ember was able to do that React found really hard to do, because React didn't have a template language which enforced constraints. Yeah, that was my slide. Okay, so we've talked a little bit about keywords and helpers, but what is the difference? So remember that good language design means that user-defined functions can be used like a primitive. And keywords in Ember are Handlebars primitives, and they operate on a much lower level than Ember helpers. So these are all the keywords that you've probably used in Ember, and I hope you're familiar with some of these. And although you invoke these keywords like you would any other component of helpers using the double curly syntax, they're definitely very different. And keywords are reserved, obviously, and they have access to different things. For example, like a keyword can access the template itself, the scope of the environment, and so on. While helpers only receive the parameters that we pass into it, as well as the options. And here, if you know, I don't think you can see my mouse. So this helper foo, it takes these positional parameters, model and ABC, and async equals true is the options that are passed into it. So even though helpers aren't as powerful as keywords, you can still do some really interesting things with them. So we've talked a little bit about UI as a language, so let's explore what declarative templating means. Being declarative means that templates communicate intent as much as possible. You're describing result, you're not telling the computer exactly what to do. And that's because templates, even more than code, are meant to be read. And at the same time, the more code you have in your app, the more likely you are to have bugs. I've always liked to say that the best code is no code, because there's no way no code can have bugs, right? And relying on generic, well-tested helpers in an add-on or some other library can, in some cases, mean that you can remove unnecessary logic that you don't have to maintain and test. So templates are blueprints to describe the result that you want. And instead of embedding data inside code, in templates we essentially turn things inside out and we embed code inside data. The converse here is embedding data inside code. And if you think about it, this actually only produces HTML as a side effect of this code running. The code doesn't describe the result at all. And even though this way of generating HTML is probably more powerful and more flexible, you can probably agree that the previous example was a lot more easier to reason about. So embedding logic in data is what modern template engines use. And since Ember is becoming more template-driven, we need to look at the spectrum of logic again. So there is a fine balance to be achieved. Obviously we can't have no logic, but on the other extreme, we don't want to have all the logic. So let's look at some examples. Okay, here we have a computer property to filter employees. Our logic lives on the component as a computer property, and it's still okay since this logic isn't very complicated. And for those who are not familiar with a computer property is essentially a property on an object that is automatically updated when one of the dependent values change. So here, this computer property is observing this employees property, and whenever that employee's property changes, this computer property will update. So now let's say you wanted to group those filtered employees by their role. Now you've got to add a bit more presentational logic, more computer properties, which are kind of hard to test, because once you try to reuse these computer properties, it actually becomes quite difficult because you need to know how to make a computer property macro, which is probably not very straightforward and can be also very complicated because you need to determine how you get those dependent keys into that macro. Or you could even make a mix-in, which is kind of error-prone, and personally I don't really like mix-ins too much. And on the other hand, you could use helpers to eliminate those computer properties and do the filtering and grouping of the employees directly. Now this approach shifts the presentational logic into your template in a declarative way. And if you wanted to, you could even take it a step further and compose those two helpers together. This is a little bit more concise, but definitely harder to read in my opinion. And I think that this is most likely the most nesting I would do. Now, which is the better approach? I think a very common theme in this talk and many other talks is that, like anything in life, it's a trade-off. If you find yourself writing very many generic boilerplate computer properties, it could be a good candidate for being extracted into a helper and then using that as a macro in your template so you don't have to repeat yourself so many times. But then on the other hand, you also need to have this balance where you don't want to get too carried away with these helpers, and you only want some logic in your template, not all the logic. So we should strive to stay within a sensible limit. And the previous example I showed where I did the grouping and filtering in the template was probably pushing that limit. And I wouldn't really recommend it too much unless you really knew what you were doing and you could communicate that well to your team. So if there's one lesson you take away from this talk is please don't program in your template. Just because you have these cool helpers available doesn't mean that you need to abuse them and combine them in really interesting ways. And Handlebars strikes a really good balance in the amount of logic that you have in your template. And if you think about it, it's a really well-designed templating language, and it enables nice domain-specific languages like Ember Form 4. If you've done any Rails, you'll see some familiarity here because everyone loves building forms. Okay, so now with that out of the way, let's look at how we can write some awesome helpers. So I work at Netflix, so I like TV, obviously. There is a documentary called Jiro Dreams of Sushi. Jiro is a sushi chef in Tokyo. He's really old, but he has a 3 Michelin star restaurant, and he's devoted pretty much his entire life to sushi. And it's a really interesting documentary if you like food. And in this documentary, he said something that has stuck with me for a very long time. He basically says that you must eat delicious food in order to make delicious food, and you can't make good food without good taste. I think this quote applies to programming as well, and even any other creative pursuits you might have in general. And this was even more so when I listened to Guy Steele's talk on growing a language, which I highly recommend. In other words, to write good helpers, we should first understand what good helpers might look like. A good helper must be pure, and Ember makes no guarantees that multiple uses of a helper will run at any given point. For example, this capitalized helper is going to only be run once, even though it's being used twice. And this is good as Ember can optimize rendering, but that means helpers must be carefully written to not rely on side effects. Let me get some water. Here is a really simple addition helper with no side effects. And because it's pure, and when I say pure, I mean it takes some input, it returns some input, it doesn't modify anything outside of it. And because it's pure, this will always give you the correct result. Now here's a really badly written helper with a side effect. I hope no one has written something like this, but if you did, don't do it. So here, X is being modified from the outside, and this will lead to really, really strange behavior because the whole point of the Glimmer rendering engine is that Glimmer will efficiently re-render your app multiple times. And because this helper might be run multiple times, this value will actually keep changing and it becomes non-deterministic. And on the other hand, pure functions will always give you the correct results no matter how many times you do the rendering. Now you're probably thinking to yourself, right, that was obvious, like I would never write code like that, right? But that was really a simple example because values in JavaScript are immutable. But you have to be really careful when the arguments to your helper are an object or an array. Because in JavaScript, objects and arrays are passed by reference, not value. So this looks like a fairly innocent sort helper where you pass in the order, ascending or descending, and an array of items to be sorted. And then we basically just use the sort method on that array and return the sorted array. So it looks fairly innocent, right? But what that means is when you modify that array in place, it actually modifies it for everyone else. This is a really cool GIF I found that shows you the difference between pass by reference and pass by value. So you can see on the left, you pass in cup as an argument and you run that method fill cup. And what actually happens is cup itself is being updated, whereas on the other side, it only the passed in cup was modified. So what I'm getting at is that the sort helper I wrote previously is flawed because after you run that helper, the numbers array here is actually mutated. So the first time I output numbers into your template, it says 2, 5, 4, 1, 3. After I sort it, it's 1, 2, 3, 4, 5. But when I try to render this same array again, you will notice that it changed. When if you think about it, a helper should really only be presentational. You never want it to actually modify the actual data. So you got to be very careful when you're dealing with helpers. And if you deal with objects or arrays, there might be some ways around it, like like making a clone of that array or object instead, or like using functional methods like map, filter, reduce, which return new arrays. And then one thing about when you design helpers is you can also think of them as ways to use modules or even add-ons in your template. So yeah, I'm plugging all my add-ons today. I made an add-on called Ember change set. And what a change set is basically a fancy word for saying a collection of changes that you want to apply onto something. So a change set was inspired by Ecto, which is an Elixir, another programming language library that is a kind of like a nice domain-specific language for creating SQL queries. And it gives you a really functional approach to modifying data and also being able to validate that data. So ignoring the whole change set concept for the meantime, I'll show you how I use the helper as a main interface for creating those change sets. So you don't need to look too much into this, the logic here. It's basically all you need to know is that this change set helper takes some object or some model and it returns you a new object, which is a change set. But like writing this in JavaScript doesn't communicate intent as well as it would in the template. And the helper basically lets you abstract away the logic you need for accessing these change sets. So now when I create a change set, it's very clear in the template that it's a change set, and it's very clear that this change set is operating on the user object with the employee validations attached to it, and it's straightforward to read when you're going back to trying to modify this form. So my point for that is that it may not be obvious, but whatever your helper returns dictates how it's used. When you return these primitives, it's fairly straightforward, and they just return the value. There's nothing too exciting about this. Like if you have, like my join helper returns a string, my sum helper returns a number, my greater than helper returns a boolean. So that's pretty straightforward. But it gets a little bit more exciting when your helper returns an array. Here is an example of a repeat helper where you can pass the helper some value and it will just repeat it however many times you want. And the code might look a bit complicated, but it's actually really simple. It's creating an array with the length that you pass into it. So in this case, maybe I say I want to repeat foo 3 times. It will create an array of length 3, and then it'll map over that array and give you a new array back containing 3 foos. And not surprisingly, you can use each helper when you return an array. Or in fact, in any other keyword or helper or component that expects an array, you can use that sub-expression right in there. And I mean, you can already imagine some interesting use cases for this in your application, particularly if you're dealing with a lot of like boilerplate code like this, where maybe your designer wants you to repeat some marketing copy like 10 times for some reason, and you being the awesome developer you are, you don't want to copy paste that 10 times. You want to use this cool helper, right? So what about objects? Now, using the chain set example again, you could use the with keyword to make a simple, really crude form for. So the with helper will basically take the result of this helper chain set and then yield that as a block parameter inside this block of HTML. And you can use this not just with the chain set helper, obviously. You can use this with any other helper in Ember. And when you return objects, you could even do something as crazy as this, or what I call the contextual helper, the helper version of a contextual component. This is actually a really stupid example, but when I first realized you could do this, I thought it was kind of silly but cool. But it turns out that you can actually use this technique to do something that you might already be familiar with in object-oriented programming, and that is dependency injection. So to explain what dependency injection is basically saying that you take away the dependencies that some object relies on and you explicitly pass it into that function, is a simple way of explaining it. So here you can imagine we have some really complex UI component with 3 child components. Here I have a map, a sidebar, and a form. And you'll notice that instead of using those components directly in the template of the complex component, I'm passing in those components as arguments into this hash called UI. And what this basically does is it lets you decouple those presentational components from the parent or the container component. And your parent no longer needs to know anything about how these components work. And here is here is a component integration test helper, which basically will let you test your components in isolation. So we can register dummy components to stub out those child components. So in our component integration test, we no longer need to know anything about those children components. And for example, if I only wanted to test some behavior of the complex component itself without having to worry about setting up the map nicely and like stubbing Google Maps and stuff like that, you can just stub the whole component out, and now you no longer have to worry about that kind of like boilerplate setup. So as you can see, what you return in the helper really changes how it's used. And not surprisingly, you can even return a function in a helper. And this is probably my favorite use of the helper. Here is a toggle helper, and this will basically, as the name suggests, it will inverse the property on some object. And in JavaScript, a function that returns a function is known as a higher order function, which is a fancy way of saying that it takes in a function as an argument and it also returns a function. And a higher order function helper will essentially let you make action helpers in Ember. So now in my template, I can write this instead of using my custom toggle is expanded action, which you've probably written many times in your application. And you can abstract this as a helper, and because it's so generic, you can pretty much reuse it anywhere, and you don't need to repeat that this toggle is expanded logic anywhere else. Higher order functions also take in other functions as arguments, and in Ember, because actions are functions, this add-on Ember Composable Helpers has a helper called the pipe helper. And what this helper does is it takes in those 3 actions and it composes them into one action. And what happens is when I click on this button, it will first invoke the first add to cart action, and then the result of that action is passed to purchase, and then the result of purchase is passed to redirect to thank you page. So that's actually pretty cool, right? And you can see how this might let you clean up some of the boilerplate presentational logic you might have, where you click on the save button and then the drop down appears and then this thing spins. You've probably written some terrible action in your component where your action not only has to deal with that business logic, but the presentation logic at the same time, and it's all like muddy and you don't know what's going on. And the code for the helper is actually very little. But again, it can dry up a lot of boilerplate UI stuff. So circling back to what I said earlier, helpers aren't as powerful as keywords, but as I hope I've demonstrated, you can do some really interesting things with them. All my previous examples were the simple form of helpers where you pass in a function to the helper method. But for more complex needs, you can make a class-based helper, which you can think of as kind of like a component without a template. And what that means is you can use computed properties, services, and even access the container and whatever crazy things you want to do. Here is an I18N internationalization helper, where you can look up translations on a locale service. So even though we aren't passing the locale into this helper, whenever that locale changes, these translations in my application will automatically update, which is really nice. And you might actually have noticed an observer, a wild observer appears. Currently, because helpers don't have the same hooks like components do, like like did insert element or did receive adders, like all these nice hooks you have to run some kind of code. Unfortunately, we still have to use, we still have to use observers and helpers. But from what I've heard, hooks for helpers might be coming sometime. So for now, it's okay to use them, but don't use observers anywhere else. Especially for people who are new to Ember, pretend observer doesn't exist. Okay, so you're probably pretty excited about these cool helpers I've shown you. But let's answer this question. When should you prefer to use a computed property, and when should you use a helper? The first thing you learn about in Ember is most likely a computed property. And computed properties are a nice way of computing values automatically. But these auto-updates can be a bit of a double-edged sword. Computed properties are best suited for business logic. But sometimes knowing what keys that you need to observe can sometimes be tricky. For example, here I have an annuity method, a computed property, and this basically is the value. I forgot my finance. It just gives you some number, just think of it that way. And it takes in these dependent keys, the payment, the rate, and the periods. But sometimes you're not always so lucky, and you need to determine what those dependent keys are at runtime, which is actually kind of complicated, and it's also kind of hard to extract and to make reusable. For example, what if these keys names were dynamic? What if someone else could pass in the value for the keys? Then how would you write this computed property when you don't know them in advance? Helpers, on the other hand, you don't have to worry about dependent keys. And helpers are best suited for generic utilities such as the repeat helper, the toggle helper that I showed you earlier, and just generally dealing with very generic UI logic. I think helpers are a great fit there. But of course, don't remember not to get too carried away with helpers. Obviously, this is bad, so don't do it. And in conclusion, templates are logic embedded in data, and the amount of logic in your template lies on a spectrum. Handlebars enforces a separation of concerns, so don't program in your template. And always remember the rule of least power, which is to use the least powerful language for a given task. And since templates are the language in which you compose and build your user interface, keep it declarative. And how much logic you have in your templates is a fluid amount. Sometimes a little bit more is better. Sometimes less is better. I think it really depends on the nature of the team and how comfortable people are with using these helpers. So again, it depends. And but you can generally think of helpers as a really good way of drying up this boilerplate UI logic. And finally, what your helper returns changes how it's used. You can return anything from a string, array, object, functions, anything in JavaScript. And many different use cases can emerge from this, some of which I might not even have known about. but you might discover something if you give it a try. And then if you need access to services, computed properties, or other kinds of stateful things, you can use the class-based helper. So that was my talk. I hope you haven't forgotten my name. It's Lauren. And thank you for listening.
Do you want any questions?
Oh, sure. Yes. Does anyone have any questions?
Are your slides going to be up anywhere that you see them?
Yep, they're on speaker deck. I'll put a link up after this. Yes?
So before Ember Composable Helpers, I had written my own type helper, and it's kind of like changed the way I've written a lot of my JavaScript.
Yeah.
Like I'm not using push anymore. I'm using like only slice.
Yeah.
Like all of these like non-mutating functions, and I was just curious because you had a lot to do with Ember Composable Helpers. You were writing JavaScript now that way too.
Yeah, so I actually watched his talk. I think you presented it at this meetup, right?
Yeah.
It was a really good talk. You should check it out on, I think it was also called declarative templating. I can't remember the title.
It was to do HBS.
Yeah, to do HBS. Yeah, it's a really good talk. Definitely go check it out. Basically, he mentions how he was able to clean up a lot of the UI logic he had in his application using the pipe helper. Ember Composable Helpers was definitely very influenced by his talk. So thank you. And we've taken that helper and we've made it a little bit nicer to use in Ember because I didn't mention it, but the pipe helper is also promise aware. So that means if any of those actions return a promise, it will actually wait for that promise to be resolved and pass the return value into the next. So you could, for example, you might save some model and then return the result of that model to the next action. And to answer your question, yeah, it's definitely changed the way I write JavaScript. I think there's definitely a bit of a paradigm shift in people's attitudes towards functional programming, where like things like immutability and no side effects and all that kind of thing have taken, I guess, I'm not going to say, yeah, they've become popular, put it this way. And I think it's a really powerful tool to be able to use. Yeah, so I definitely hope to do more functional style JavaScript because it's made my programs a lot more easier to reason about. And in some cases, it can even eliminate whole classes of bugs when you deal with your data as if they were immutable.